Hey there, systematics! Welcome back to Cell to System, where cells become systems and learning rocks. If you're new here, buckle up, because today we are diving into one of the most beautiful biological performances ever, the ovarian cycle. The ovarian cycle is easiest to understand when we slice it up into three parts. The follicular phase being the first one, ovulation being the second, and the luteal phase being the third. So we have the follicular phase, the ovulation phase, and the luteal phase. We are going to be focusing on these three main parts as we go along the video. We will use the classic 28-day cycle for simplicity, but remember, many cycles range from 28 to 35. The follicular phase occurs from day 0 to 14 before ovulation. Ovulation occurs at day 14 and the luteal phase occurs from day 14 to 28. Before we jump in, let's meet the management team. Because yes, even your hormones have bosses. This is what we call the hypothalamus pituitary ovarian cycle. The hypothalamus is the CEO, the big boss. The anterior pituitary is the middle management, and the hardworking employees are the ovaries. So this is what happens. The hypothalamus secretes GnRH to the anterior pituitary, which then causes it to secrete FSH and LH. FSH and LH tells the ovaries to produce estrogen and progesterone. So basically, the hypothalamus is telling them, hey you, do this, hey you, do that. I'm the boss. And in the end, there is estrogen production. Okay, let's jump right into the first phase, follicular. Like we mentioned earlier, GnRH release from the hypothalamus causes FSH release from the anterior pituitary gland. FSH then taps the granulosa cells of the ovaries and tells them, hey pal, it's time to grow some follicles. The follicles start developing, but only one becomes the chosen one, the dominant follicle. The rest degenerate and undergo what we call atresia. Sorry, maybe next time, pal. As the dominant follicle matures, it pumps out 17 beta estradiol, the most potent estrogen. The primary functions of estrogen include maturation of primordial follicle to the Graafian follicle, and inhibiting GnRH secretion and LH secretion through what we call negative feedback inhibition. But estrogen is sneaky because as the levels get really high, it flips the script from negative feedback to positive feedback inhibition. Suddenly, it's like more GnRH, more LH. This estrogen switch up triggers the LH surge, a dramatic spike in LH levels. Think of it as the plot twist of the cycle. So what we're saying is we have the Graafian follicle secreting high levels of estrogen. This in turn causes the anterior pituitary to secrete high levels of LH. The next phase is ovulation. It occurs around day 14 of a 28-day cycle. Thanks to the LH surge, the mature follicle ruptures and releases the secondary oocyte. Ovulation, put simply, is the egg yelling, I am free, and diving into the fallopian tube ready for fertilization. The luteal phase is the final phase, which means we're almost there, systematics. After ovulation, the ruptured follicle transforms into the corpus luteum. The corpus luteum produces a main hormone called progesterone. Progesterone dominates the luteal phase. Its functions include maintaining the endometrial lining and preparing the uterus for possible implantation. It's basically turning the uterus into a 5-star Airbnb, if you get what I'm saying. If there is no pregnancy, the corpus luteum degenerates and it results in low levels of progesterone and estrogen. Now we're moving on to menstruation. Regression of the corpus luteum leads to a sharp drop in estradiol and progesterone. This hormonal drop causes the endometrial lining, the beautiful Airbnb, to shed, resulting in what we call menstrual bleeding. Menses last for about 4 to 5 days, depending with the female. After that, new follicles get recruited for the next cycle and the show continues. And that systematics is the ovarian cycle. If you learned a thing or two or 12, smash that subscribe button, hit the notifications, drop a like, and comment what system you want us to explore next. Thanks for watching. Keep exploring from cell to system.